In this lecture, we will study much further about the beam specifications, that is those specifications which we have not studied in the previous lecture. But before that, I will like you to press Shift plus O on your keyboard to switch off these local access, and I will like to delete these structures that we have just made for our education purpose. So coming back to our original structure, I would also like to delete this plate structure here. So now in this lecture we will study much more about the beam specifications, that is truss, compression and tension. But before that, I will like to add some beams here, that is we can add this beam here and this beam here, and we can also add the bracings also. So this is the plan bracing that we have made here. And now, as in our original structure we are not modeling the plate, then we can also delete these vertical offsets that we had made. So coming back to our original structure, so now in this we will understand what exactly is the compression. So by enabling a member to be compression only, so first of all we need to select the compression here and left click on add, and if we are selecting this bracing as a member compression only, so only and only axial force will be traveling in these members, and only and only compression force will travel here. And when we will select tension here, so only and only tension force will be present here. And there is this one more thing, that is truss. So by selecting truss, both compression as well as tension can develop in a particular member. So for example, if we make a member like this at the center and we select it as member truss, so only and only axial force will travel in this member. Not a single unit of moment will be developed in both of these members. So this member truss has to be used judicially while you are modeling a structure, as any incorrect or excessive truss specification can lead to instability in the structure also. So now we have understood how we can assign compression, tension and truss specifications. After that, there is this one more thing called fireproofing. So if our structural steel members have fireproofing also, then we can assign this specification also. Here there are two parameters, that one is the thickness and the second thing is density. And this fireproofing type, one is the block fireproofing, that is whole of the structural steel member is embedded in a fireproofing material. Second is a contour fireproofing, that is the structural steel members are covered in a fireproofing material in their particular contour only. So now this thing is clear to us, that how what is the basic difference between contour and block fireproofing. If we will Google about this, then this is the practical scenario on a site. Here you can see that this is the contour fireproofing, that is the fireproofing is done along the contour of this structural steel member. Same is the case with the beams here also, that is fireproofing is done along the contour of the structural steel member. So if you will Google the block steel fireproofing, then you can get this result here. But I hope you are understanding the scenario here, that how the things are done on the site. So now we have studied about the fireproofing specification also. There's this specification called imperfection specification. Imperfection is like when we are assigning a particular pre-camber to the structural steel member. Pre-camber is done when the span of the beam is very high. Let us say it is in the range of 12 meter or in the range of 15 meters. Then the structural steel member shall sag in its own self weight only. So to avoid that, what we need to do is that we can assign a particular pre-camber to the structural steel member, and to assign or to consider the effect of this pre-camber on a structural steel member, then we can assign pre-camber here. Let us say the value is of the pre-camber is approximately 25 mm. So we can assign y, and we need to select the local direction. So we need to select the local direction according to the axis that is being visible here. And drift is like when a particular structure has already a pre-installed drift in the structural steel columns. So drift is like the in simple what we can say is the deflection that has already occurred in our structural steel member. So if we are considering that, then we need to assign the drift specification. And one more thing that I'd like to add here, when we are considering the camber, there is this respect called 1.6. Actually, STAT calculates the epsilon for the calculation of this pre-camber, and when that epsilon according to this respect value is not considerable, then STAT does not consider any effect of this pre-camber. But when both respect and this pre-camber value, by considering both of these values, the epsilon is somewhat high, then the STAT basically consider the effect of the pre-camber. And in Indian codes, you can take pre-camber up to the for the specification up to the dead load plus 0.25 times the live load. And similar is the case with the American codes and Euro codes also, that these codes too define some pre values for the pre-camber specifications. So now we have studied compression, tension, inactive member. Inactive member means that no force will travel through a particular member. So when we are selecting inactive member here, let us say in this channel no force will be transferred, so we can assign this member as inactive. And when double clicking this member here, we can see that this member is assigned as inactive member. So now we have studied fireproofing, imperfection, all these specification we have studied. Truss we have also studied, and release we have also studied, offset we have also studied. Now property reduction factors and cable specification. Cable specification that we will discuss in the separate lecture series that we will study in the advanced non-linear cable analysis lectures. But property reduction factors is what our ACI code, our Euro code, and Indian code also, and Australian code also guides us about the cracking coefficient properties. But before assigning these properties, we can model a RCC beams also. So we select these joints here. Select the global direction as Y and default stress spacing as -5 meter and link strips. And we can make a floor here. We can model a secondary beam here also. So by selecting these members, we can left click on add midpoint and then left click on add beam here. So now we have modeled a RCC beams and column system here. So we need to go to general and property. Here we can go to left click on define. Here there are various features. So selecting rectangle here. So now again this is the Y and this is the Z. So selecting thickness of the beam as 0.3 and height of the beam as 0.5. Material as concrete, left click on add. So now we need to select these beams here. Yes. And similarly we can define the size of the columns also. Let us say 0.4 by 0.4 meter. So if we will select this beam and check in isometric, here we can see that this is 300 mm, this is the 500 mm dimension. And similar is the case with this. This is 400 by 400 mm column. Although we will need a bigger size column because our structural steel member is 457 size. So let us say we increase this its size to 650 mm to 650 mm. So now this is basically a composite structure that we have modeled, that is RCC structure on the bottom and steel structure on the top. We are modeling this structure just to like make you familiar with all the specifications that are available in the STAT software. So we go back to general and specifications, and we go back to beam. So in the property reduction factors, as ACI code and Indian code both guides us that the reduction factor for torsional constant and moment of inertia, all of them shall be 0.35 for beams. So we have entered 0.35 for all the RIX, RIY and RIZ, and similar is the case with the columns. We need to assign 0.7. Left click on add here. So selecting the columns here, and selecting the beams here. So now we have assigned property reduction factors to the beams here also, as well as columns also. This is also a thing that is not mostly done by the engineers, but that needs